Joining us this morning here in the studio once again, he was here yesterday, Jim Vucinovich, a litigator for more than 30 years. He has tried several cases involving train derailments, and we're happy to have you back with us again this morning. Really appreciate it. Let's talk about the speed. We talked about it yesterday, and it does appear that speed was the factor that sent this train barreling off the tracks. What does that mean for the investigation? Well,
I mean, that's going to be a primary consideration and focus. All these train tracks are regulated and they have posted speeds that they can't exceed the maximums. We know that this train was coming off a stretch of track, actually going downhill on a 1.5% grade and then banking into this 45-degree turn. It was supposed to be going from 80 miles an hour down to about 30. And in order to do that, the engineer has to obviously take control of the train, apply the braking, and then go into the curve. For some reason, they were way over speed. And you know the launch angle of where that locomotive went off, it went straight off the tracks, indicating that it was going at a high rate of speed.
The mechanics of braking, is it like an automatic car where the engine will sort of automatically slow down itself, or it's on the engineer to physically pull a handle or push his foot?
Passenger trains are equipped with two sets of braking. One is called an automatic braking, which is an airline system which maintains pressure to keep the brakes on or off, and then an independent brake on the locomotive itself, and so it can be used in combination.
Positive train control, Amtrak says it was not using that kind of technology to slow the train down. Could it have had that in use, and would that have made a difference, and will that be a factor in litigating something like this?
Oh, I think definitely. Positive train control is a technology that's been around a long time, particularly in Europe. It's only late to the game here in the United States, but that technology clearly would have been a redundant system which would have then automatically reduced the train speed if the engineer was distracted or some other catastrophic failure had been occurring.
Is it just a calculus of how much money it costs to implement that? Otherwise, why wouldn't it be in place?
In my opinion, I think the capital cost has been the primary reason for the delay. Our freight railroad systems, have lobbied Congress in order to extend the deadline in which to implement that procedure.
And one of the passengers on the train said that as the cars derailed, it catapulted, and that was the word that one of the people on board used, catapulted the people into the seats in front of them. The injuries are really severe for some: head injuries, neck injuries, spinal injuries. When you see these kinds of derailments, the long-term effects are great, aren't they?
Oh, there's no question about it. I mean, fortunately, some people, walked away from this, but others are going to be struggling with the disabilities and injuries, for the rest of their lives, and it's going to impact them and their families, for a lifetime.